I have managed, you should just call me Superwoman at this point, Wonder Woman. I managed to finish your test review and the key with all the work and upload and make copies, staple, 3-hole punched. Yay, me. Okay? So I have these available for you today if you want them. So once I'm done with notes, I'll come around and offer it to you. Don't feel like you have to take it early. This assignment isn't until next Tuesday. It's Thursday, obviously. So the reason I'm making sure I get it this early to you is because, if you miss the review day on Tuesday, and then maybe I see you Wednesday, I don't know, whatever the SAT business is. Some of you won't come that day, or maybe you leave after the I don't know. Maybe you'll be here. But it'll definitely be a weird day, Wednesday. And the test is on Thursday, okay? So by giving this to you this early, no one will have an excuse not to take the test next Thursday. It's 9 multiple choice questions and 1 FRQ. So it's a 1-day review, 1-day test, okay? Lots and lots of calculator work, finding intercepts, mins, maxes, zeros. So a lot of the same skills that we've used a lot in this class are on this test, okay? So that's breaking news. Today we're finishing 3.10. Tomorrow, Monday, 3.11, and then review on Tuesday, whatever happens on Wednesday, test on Thursday, makeup day on Friday. Okay. So we have 2 examples to do and 4 homework problems to do. So in total, 6 problems, of which I do 4 with you. Okay? So, and then you'll do the last 2 on your own, have lots of time left over. So let's make sure we ask good questions and pay attention. Because when I first started explaining this first one, some of you, most of you, all of you, I don't know, will be a little confused. And that's really, really normal. And then when I get to the second one, you'll be like, okay, I'm starting to get it. And then by the time I do the first one, the homework, you're pretty much there, okay? And I'm speaking to the most, like my average kids. You guys are a little above average, so maybe it'll happen a little bit faster. But just understand it's okay to be a little confused in the beginning. Okay, so what we're doing is multiple angles, solving equations that have multiple angles in them. And what makes a multiple angle is there being a number hanging out with x. So this is a multiple of 2, 1/2 to 1/3. If you remember yesterday and the day before, a question like this would have just looked like this. It wouldn't have had the 2 there, for example. So this is actually how we start the problem. We ask ourselves, what would we have done yesterday? What would the answer be to this problem if it was yesterday and it didn't have a 2 in it? And so remember our reference angle, all students take calculus, whatever you need to do, but you come up with your answers, okay, which is denominator of what for tan with this one? 3. And tan is positive in quadrant 1, all students, and 3 take 4. Okay? Now, if this was yesterday, these would be our 2 answers, because it's on 0 to 2 pi. We'd list both of them. But remember when it would say tan, find all solutions, where you would have to put the plus pi n at the end? We are going to pretend it's that type of problem in the beginning for a reason you'll understand in a minute. So whenever we do tan, we only need the first angle that we come to in the unit circle, okay? And this will make more sense in a second. Just stay with me. But the answer isn't pi over 3. That's why I have it over here in the corner. The answer is something else because of that 2x. So now let's incorporate the 2x into our angle. Okay, we're going to find the multiple of it. And we're going to also put that pi n on here. That's why we only need one of them, because if we'll hit this angle using this, but we'll come back to that. And I'll explain why in a second. She's been a little temperamental today. I have no idea what makes that happen. I really don't. It's like I use the same 4 colors. It's the same ones. Anyway, all right. So what we're going to do is solve for x, okay? So I'm going to divide by 2 or multiply by 1/2, whichever one works better with the numbers we're working with. I divide by 2 here and here, but if I divide a fraction by 2, then I have to keep change flip, which just becomes multiplying by the reciprocal, okay? And when we do this step, we actually get our first solution, which is when n is 0. So n is going to be the number of times we hit, we go through the quadrants of the unit circle, if you want to say it like that. N is 0. That's our starting amount. So our first angle is just pi over 6. I'm just going to box it. So just understand n is 0. So if n is 0, that makes plus 0. Okay? Now we're going to do n is 1. So from pi over 6, we're going to find the next one. Okay? So what we just did, kind of pictured on the unit circle, we were at pi over 3, but when we did the times 2, or divide by 2, it moved us back a little bit, right? So we were here, now our first angle is pi over 6. And so we're going to do n is 1 and so on until we fall off the unit circle, okay? So we can't go above 2 pi. Well, we're well below 2 pi right now, so let's just keep going. So here's the confusing part, so pay attention here. So I'm at pi over 6, right? That's where I am right now, and I want to find the next one. So what do you think I would make n? 1. I'm going to go to the next one, okay? So that's pi times 1 over 2, but I need a common denominator, right? So I would say the worst part of today, if there is a worst part, is having to deal with fractions, 4th grade level fractions, and I don't say that to insult you as usual. I mean 4th, 5th grade math back when you didn't have a fraction key, before you were introduced to calculators and how wonderful those were, where you had to find common denominators on your own. So that would be pi over 6 plus, what would my new denominator be? It would have to be 6, right? So if you need to go off to the side somewhere and find what your common denominator would be, totally fine. I'm at pi over 2. I need to find the equivalent fraction that's a denominator of 6. So that's going to be 3 pi over 6, right? So pi over 2 is the same as 3 pi over 6. 3/6 reduces down to 1/2. That's what that is, 1/2. Okay, so 1 pi plus 3 pi is 4 pi over 6. This is our second angle, but we can simplify that, right? So I'm going to simplify it, and that will become 2 pi over 3. There is our second angle. And we're going to keep going until, like I said, we fall off the unit circle. So understand that we're just going to reuse, I call this my magic number right here, sometimes a little elementary school for you. So I don't have to keep finding common denominators. I'm just going to keep adding 3 pi over 6, 3 pi over 6, 3 pi over 6 until I get above 2 pi. So watch, watch, watch. Even though this is my final answer for this part of the unit circle, I'm going to use its equivalent fraction that had a denominator of 6. That way I can add these two together, meaning I would have, I'm at 4 pi over 6, which, guys, is the same as 2 pi over 3. These are the same thing. Why? Just laziness. This way I can just use that same 3 pi over 6 to get my next angle, and I don't have to find common denominators again. You might be wondering where my n went. Okay, so I'm going to explain where n went right now. My first one was n is 0. My second one was n equals 1. Why didn't I make the next one n is 2? Well, think about it. We're not starting at pi. We started at pi over 6, and we did n equals 1. Well, if we're going to use n equals 2, we would have to add it back to this one, because it would be 2 away from this one. We're going from here. We're now at 2 pi over 3. We're going 1 away from our most recent angle. That's why we don't have to keep changing the n value. Once we get to n equals 1, we just use that same fraction over and over and over again. So now I'm at 7 pi over 6. I'm still on the unit circle. Let's see what happens next. 7 pi over 6. What am I adding to 7 pi over 6? 3 pi over 6, which is 10 pi over 6. Am I still on the unit circle? Yeah. What's the top number going to be when I'm not on the unit circle anymore? 12, right? 12 over 6 would be 2, okay? So this one's still good. I'm going to go ahead and simplify it, right? Always simplify our fractions. We get 5 pi over 3. Can we go any further? The answer is no. Think about why. If I add 3 pi to that, I get 8 pi over 3. 8 is more than 6, so we can't go any further. So those 4 that I boxed are my reduced ones, and those are my 4 solutions. Okay, so instead of having 2 solutions on the unit circle, we ended up with 4 solutions on the unit circle, and this helped us find them. Okay, let's do another one. That was the hardest one we're going to do today, because it had some simplifying in there and stuff like that. A lot of them don't have that. Okay, so here's another one. Find all the answers on the unit circle. Here it is. I notice it's a multiple angle, so I'm just going to go off to the side and answer, what would it be if that 1/3 weren't there? Okay, so sine is 1/2. That would be at my denominators of 6. It's my reference angle. And then sine is positive in quadrant 1 and in quadrant 2. So that would have been the answer yesterday and the day before. Okay. And notice I didn't cross one out here. For sine and cosine, I have to work with both of them. But I promise you it's not a big deal. So come back over to the actual problem, and now we're going to incorporate that 1/3 into our angles. So that's x divided by 3 equals pi over 6, plus, now I used pi n, and the last one, this is 2 pi n. Sine and cosine have a period of 2 pi. This is why we have to do both of these. So I use like this little 2-column method. And I'm doing the same exact thing I did up there. X divided by 3, that's what this is. So to get rid of it, I would multiply everybody by 3. Arlen, you cannot sleep in this class. I'm not going to tell you every day. So these cancel. I'm left with x. Guys, that's 3 pi over 6. Okay? I'm trying to save us some work here. 3 pi over 6. Can I just simplify that right now and make it pi over what? 2. When n is 0, that's our starting angle, our first angle. Now we're going to continue and see if we can find some more angles. So I need a common denominator for 6. That's a denominator of 2. How can I make a 6 with a denominator of 2? What would my numerator have to be? 12, right? 12 pi n, that equals 6 pi n. That gives me 13 pi over 2, because n is just 1. Talk to me about 13 pi over 2. It's way off the unit circle. Which, thank you. Yeah, this is not going to be part of our solution set. And this should have been a hint, right? 6 pi n is 1, 2, 3 revolutions around the unit circle. Yeah. So I need to get so I have 6 pi n over 1. That's what this is. I need a common denominator. So what denominator do I need? 2. So I did this times 2 and this times 2. Okay. So one solution on that side. Let's go over here and do the same thing. So multiply by 3, multiply by 3, multiply by 3. Without even simplifying it, guys, look what I get. 15 pi over 6. If I double 6, I get 12. That would be 2 pi, right? 12 pi over 6 is 2 pi. I'm over it already. I get no solutions from that one. So the smaller your multiple, so like a fraction less than 1, the fewer answers you get. Think about why. Because I'm multiplying the other side by that number, which makes a much bigger period. Okay? So there's only one solution to that problem, and that's pi over 2. Why didn't I do the 2-column method here? Just so you know, people forget all the time, and they'll do like the other column, and they'll do this one, which doesn't hurt you at all, but you'll just be mad at yourself because what you'll get is 2 of these same solutions, okay? So when you do this, you'll get 2 of these solutions, and you'll be like, wait a second, why am I getting duplicates? Oh yeah, I didn't need to do the other, okay? So with tan, you only have to do 1. All right, let's see what the homework looks like. I'm going to do the first 2 with you, just to make sure you have it. We're just on the back of yesterday's homework. same section, practice set. We did 1 through 12 yesterday. We're at 13 through 16, C28. Ready? Okay, so I'm going to do 13 and 14 with you. Guys, remember we had this conversation. You can have theta, you can have x. It doesn't matter what you use as long as you know that that means it's an angle. Okay? That is an angle that x represents, theta represents. Okay? So if the 2 weren't there, it would look like this. And my 2 solutions would be denominators of what? 3. And cosine is negative. All students take calculus in quadrant 2 and 3. Okay? But it's not that problem, right? There's a 2 in there. So we're going to multiply or divide that 2 back into those. So we have 2x equals 2 pi over 3. This is a period of 2 pi. And we're going to have to do both. Anytime you have sine and cosine, the period is 2 pi, and we have to do both of the angles. Could you only have one angle over here with sine or cosine? Yes, with a quadrantal. Okay, but the middle ones, you'll always have 2 solutions. All right, so divide by 2 or multiply by 1/2. Divide by 2 or multiply by 1/2. Okay, so I get x equals, this is 2 pi over 6. 2 pi over 6 right here, which I can simplify down to pi over 3. So when n is 0, that is our very first solution. Okay. Let's keep going. We are at pi over 3. Now let's put a 1 in for n. That's 1 pi or just pi. Pi is the easiest one to make into a fraction with a common denominator. What would it be? What number on top, what number on bottom? 3. Nope, just 3 over 3. Right, that equals 1. 3 over 3 is 1. Right. If you need to go off to the side and do the work, totally fine. Do it in your head, totally fine. Whichever one. And so what the beauty of this is, I can keep using this same fraction for the rest of this problem and on this side too. So you only have to find a common denominator once in these problems. All right, so 4 pi over 3 is where I am. I'm going to add another 1 to it. And I get 7 pi over 3. Is that right? Something's wrong. What did I do wrong? Nope, I didn't do anything wrong. What do I know about 7 pi over 3? It's right. I'm like, why isn't that my answers? So if you double your denominator, and that number is more than that, you're off the unit circle, right? 6 pi would be 6 pi over 3. All right, so same thing over here, but you already did the hard part. Divide by 2, multiply by 1/2. I get 4 pi over 6 when I multiply this, which is 2 pi over 3. So when n is 0, 2 pi over 3 is another one of our solutions. And I don't need to worry about finding a common denominator. That's the beauty of using radians on a unit circle. They all have the same denominator at the same trig value. So I'm going to have a denominator of 3 here, just like I did over here. And I can use that same 3 pi over 3, which is 5 pi over 3. And we're almost to 6, right? If I added another 3 pi over 3, I would be at 8 pi over 3, so I would be off the unit circle. So 1, 2, 3, 4 solutions. Okay? question before I do 14? So I want to figure out what it would be if the 2 weren't there. And so tan, when tan is 1, what would the denominator be? 4. And we really don't need the second one. So I actually wrote that in my notes on my home on the key because I want you guys to remember. Yes, there are 2 solutions, but you only need to work with 1. And tan would be negative all students quadrant 2. So that'd be 3 pi over 4. Okay? So let's incorporate the 2x in. Don't forget the period of tan is pi. Divide by 2 or multiply by 1/2. And x equals, this would be 3 pi over 8. So when n is 0, we get 3 pi over 8. That's our first solution. Again, I'll show you, you have to have a common denominator. So we need pi n over 2 to have a denominator of 8, right? I need to find the equivalent fraction, multiplying by 4. So this is that number I'm going to add over and over and over again until I fall off the unit circle. Let's talk about that. What's that number going to be? What number is going to be in our radar? Because we're about to bust a move through some addition. What's that top number going to be? 16, right? 16 divided by 8 is 2. So you just want to have it on your radar maybe. You don't have to write it down or anything. All right, so here we go. I'm at 3 pi over 8, and I'm going to add 4 pi over 8. And I get 7 pi over 8. Still have a ways to go. And I'm just going to keep going. I'm at 7 pi over 8. I'll add another 4 pi over 8 and get 11 pi over 8. Still haven't hit 16. You are good. We're at 11 pi over 8. Let's say 18. 11 pi over 8 plus 4 pi over 8 gives us 15 pi over 8. And I can easily say, right, that if I add another 4 to that, I'm at 19 pi over 8, and I'm off the unit circle. So there's no need to go any further. 1, 2, 3, 4 solutions. Okay?